This antenna consists of a reflector, and the reflector has a diameter is about 15 wavelength at 11 gigahertz, and it is fed by horn, conical horn, and this is a circular waveguide feeding the conical horn. For the source, we use the voltage source, which is this source, and this is the voltage source, and if we go through the source manager and we view edit, then we have a modulated Gaussian pulse, and in the frequency band 9 to 11 gigahertz. If we plot the source, so this is the source signal in the time domain. For this antenna, we have, since we have here circular waveguide, the source should be waveguide source. So from the physics table we have here in CHRONOS, we have the waveguide source, and in the waveguide source, if you click on the waveguide source, we can see that we have different kinds of waveguide sources. It can be rectangular, it can be circular, it can be coaxial. So for our case here it is circular, and we have mode types which can be TE or TM modes. If it is coaxial, we have three kinds of modes. We have TE, TM and TEM. So returning back to our circular waveguide, we choose TE, and you have here, you can enter the mode numbers, which can be, you can write what is the mode numbers. If you have, for example, TE10, then you enter here 1 and here is 0. For this, since it is circular waveguide, so we use TE11, which is the dominant mode. In this example, we need to run to calculate the far field. So from the solution manual, we have here far field requirements, and if you click on the far field requirements, we have here checkbox, and if you want to calculate the far field, then you click on this checkbox. So now it is active, and now you can write what is the starting frequency and what is the end frequency and what is the number of frequencies that you need. For this example, we will write here starting frequency 9.5 and end frequency 10.5, and the number of frequency steps is 3. Then you create, and it will give you here in this table the frequencies 9.5, 10 and 10.5, and then you click OK. Now this is before you run the simulation, and the solver will run and will calculate the far field at these 3 frequencies. After simulating the problem, we can get the far zone field properties from the analysis menu, and in this dialog we can get the results of the far field, rotation pattern, directivity and gain.